Let's look where we are. We've created a new project. We've discovered the tech we might need for this project. We've put our unit test plumbing in place. Now it's time to start the project. Let's go back to our problem for a second. So what we have is we're going to create a panel that contains three shapes. We're going to enter the X and Y of where we want the shapes to go. And when we click on the shape, we want the shapes to begin to move. Let's introduce a UML diagram. UML diagram stands for Unified Modeling Language. And it's used to be really popular, but it's still really worthwhile to have an explanation of how classes are going to react with each other. All right, so in our example here, we have a shape class. So there are 6 classes that we're going to be talking about. We have a shape class. The shape class has got 2 classes, circle and rectangle has square. All right, there's the drawing class and the app error class. Shape is considered to be the parent of circle and rectangle is the parent of square. So it's said that circle and rectangle inherit from shape and square inherits from rectangle. So as we go down the hierarchy, the classes become more specific. So rectangle is more specific than shape and square is more specific than rectangle. So the abstraction goes up as we go up the hierarchy. So shape is more abstract. Now, drawing has an association with shape. Drawing doesn't inherit from shape. Drawing has an association with shape. Now, let's talk a little bit about the pillars of OOP. Inheritance, a very important concept. Circle now inherits from shape. So circle now has all of the attributes and methods that shape does, plus circle. And the same thing with rectangle. A rectangle is a rectangle and a shape all put together. And a square is a rectangle and a shape and a square all put together. Abstraction. As we move up, we understand what a shape is. If I said, do you know what a shape is? You'd say, oh yeah, I know what a shape is. But it's not as specific as saying, do you know what a rectangle is? A rectangle actually has its shape defined, where shape doesn't. It's more abstract. So abstraction increases as you go up, and it decreases and becomes more specific as you go down. That's the concept of abstraction. Encapsulation. Encapsulation means we hide things that are not important for the details. And I always use the automobile. When you press the gas pedal of an automobile, you don't know all the things it does. You don't know all the systems inside that help you go faster, the transmission, the accelerator, all the things that go in there. All you care about is that you push the gas pedal. So anything that's hidden, the detail that's hidden is an encapsulation. Polymorphism is a really cool concept. So for example, when I move a circle or I move a rectangle, the statements I have to actually execute to move a circle are different than rectangle. And you remember there was the CX versus X. So circles, you do it slightly different, but the action is the same. I always like to use the example of polymorphism is for example, in the Microsoft products, the save command is fully understood. We know what a save of an Excel document means. We know what a save of a Word document means. But the way it goes about doing it is completely different. So that's polymorphism, the same method executing, doing the same function, but doing it in different ways. And again, I just wanted to bring this up. This is the pillars of OOP. This is an important concept. This guy right here, and you can use the link on the presentation, explains it really well. It's a really articulate explanation of what those are. All right, now I'm going to spend a second talking about separation of concern. So we've just finished going through our problem-solving code, and we've gone through it from an OO model perspective, so we know how that's going to work. What we're going to now do is we're going to create the just unit tests or the functional tests to test to make sure these functions are doing what we expect them to do. And again, we did the discovery, and the reason we did the discovery is so that we know what the commands are and how they work. Our unit testing now is our problem solving. This is how we're going to solve the problem. And if we do this really well, we'll be able to have the browser communicate with the problem solving code as well. So in this particular case, I use a fairly standard model. This drawing right here is like the controller. It is the controller. This controller is what I'm going to communicate with, and that's where most of my logic is going to be that I require. Everything in here and here can be tested, and it can be tested with my just framework. That allows my index.js to be really, really small, and all this is going to worry about is things like attaching listeners and communicating the screen input to my problem-solving code. So now the second part of what we're going to do is I'm going to write testable code with the unit test framework. I'm going to confirm that code within the browser. So I'm going to do that fairly quick. That's going to be a rapid cycle. And the reason I do that is to make sure that what I'm testing is actually going to be usable within the browser. I'm going to minimize the browser dependency so it is easy to test. And then I'm going to continue till complete. So I'm just going to go through this cycle until we're completely done. And you'll be able to watch us go through it. All right, on to the next section. Let's go back and have a quick look at the class diagram. On the class diagram, shape is the parent. In many programming languages, shape could be considered an abstract class. What abstract means in most languages is that you can't instantiate a shape. You can use a shape, but you can't instantiate. And we're going to be instantiating some objects here in a few seconds. But what we're going to do is we're going to create a shape class, and then we're going to actually instantiate the shape class, even though in most languages you won't be able to do it. But I'm going to do it just to show an example of in JavaScript how this works. So we're going to create a shape class. We're going to instantiate it, make sure it works the way we think it does. And then we're going to create a rectangle class, instantiate it, and see that it works the way it does. And I'll explain a few things about inheritance. Now, in our class diagram, typically the class diagram is broken up into three sections. The name, this is the attribute, so we'll have an X, Y, and a key attribute, and we'll explain key a little bit later. And then it'll have these methods, the move method, the create element method, and a get element method. All right. And down when we get down to rectangle, we instantiate rectangle. It also will have X, Y, and key. It will also have a move, but as you can see in the rectangle, it's going to override move. So there will be two move methods, but this one will override that one. It may still use it, but it will override it. It will also have a get element, but this get element will override that get element as well. And let's just start some coding and fool around and see how that all works. So we're going to go back to our code here. And what I'm going to do is I'm going to move this guy over to there so that we can see both sides. And what we're going to do again when we start our testing is we always begin by writing a stub. So I'm going to write the stub for the shape. So the way we're going to do that is shape. Notice shape is a capital letter. Classes always begin with capital letters. Class, shape. And I'm just going to make it an empty class right now. So there we have shape. And what I'm going to do is I have to put it on the exports. So comma, shape. I'm going to save this. And the next thing I'm going to do is I'm going to create another test. This isn't going to test the plumbing now. This is going to just do a test the shape class. And what I'm going to do here I'm just going to comment this out because I will need it. All I'm going to do is I'm going to go const s for shape is equal to shape, is equal to new shapes dot shape. And I will want to pass it an xy, so I'm going to do that. I'm going to pass it 1, 2. And when this is working properly, I expect shape dot s dot x, I'm sorry, to be equal to 1. And I expect s dot y to be equal to 2. And of course, this test will fail, and that's fine. We want the test to fail. So let's save that. And of course, it's going to fail because the 2b. So if you notice right here, it says 1 is not equal to undefined, which makes a lot of sense. So now what we're going to do on shape is we're going to write the constructor. And the constructor by itself will do nothing. And I'm just going to show you. We'll do this. I'll run my test again. And again, that's not going to do anything. But I just want to show you. So again, if we look at it, it has the same error when it's not equal to undefined. And of course, you guys all know the answer to this. This dot x is equal to x. And this dot y is equal to y. There are a number of really experienced programmers that still do not understand this. All right, we're going to run this again. And we're going to see that in this case, the test passed. So that's really cool. So again, I just want to re-emphasize that in many programming languages, I would not be allowed to do this. This is considered to be an instantiation of shape. In most cases, we would say shape is abstract. It's a class that's abstract. And again, it's not something that JavaScript understands, but that's okay. For our purposes, it's going to be fine. Now, the next thing I'm going to do is I'm going to create another class. I'm going to create our rectangle class. Okay, so there's a rectangle class. And the only thing I'm going to change here is I'm going to say it extends shape. And that's all I'm going to do. No, I'm not going to do that. Just wait. To write the test, I'm going to show you something. I'm going to send it there. Okay. I'm just going to, we're going to really do a lot more work on these tests, but I'm going to create another test here. And what I'm going to do is I'm going to create another shape. In this case, it's going to be rectangle. And again, when I instantiate a rectangle, I expect the x and the y to be what I'm passing it. In this case, of course, the test doesn't work because remember the philosophy. I'm creating a stub, I'm writing a test that fails, and then I'm making the test pass. Okay, so in this case, if you notice, it's giving me exactly the same error for the rectangle. And of course, rectangle can't work. So over here, by just saying extends shape, and before I explain it, I'm just going to run it and make sure that this works the way you expect it to. And what's the bet? Do you think this will work or not? Yes, the tests pass. So let's talk about what just went on here, because this is an important concept. So what happens now is rectangle inherited the behavior of shape. So now rectangle, it has a constructor in it as well, which is exactly the same as shape. So in this particular case, that's really cool. I don't need to recode things. So now every time I do a new shape, I don't need to recode the stuff here. So can you imagine how powerful that is? All right, now the other thing that I could do, and I'm going to delete this, but I could write another constructor in here. A second, I could write another constructor. Take x and y. Now, a little trick here, it's not a trick, it's the way it works, is I can go super dot constructor. Oh, sorry, that's not right, just super x comma y, and that is going to execute my super class of this. And then just to show how this works, I can now do a log. Okay, I'm just going to save that. And now let's run this and make sure it works, and we'll explain how this works. So what this allows us to do now, okay, and this fails. And what does that fail? And again, can you see the typo? It should be x comma y. I'm going to save that and run it again. And then we'll just go through a little example of what this is doing. So our test passes, and now it says hello for rectangle. It should say from rectangle, but that's okay, from rectangle. So I'm going to delete these lines of code. Now, why is this valuable? The reason this becomes incredibly valuable is as rectangle is more specific than shape, I now have the ability of executing methods in the parent class by using the super, and then I can add extra methods below it to make it more specific. So this is a really cool idea. Again, I'm just going to take a second and make sure that's really clear to everybody. This is considered, again, good object-oriented programming by using this. So we have the parent class, this class now, which inherits from shape by using the extends keyword. It has a constructor, and its constructor doesn't necessarily have to match shape, but in our case it will. And the next thing it does now is it does a super, which executes this, and then I can put any extra code that I want in there, and I had a console log. So in this case, I really don't want this, so this would be silly. I'm not actually going to put that in. All right, we've gone through a really, really cool concept here. So now we have the beginning done by setting up a shape, setting up a rectangle. Let's go back to our class diagram again. The next part that I want to do now is I want to just start on the drawing. Now on the drawing, we know we're going to want a width and a height passed to it, and we're going to want to create a shapes structure. So let's start working on that next. So again, the next thing we do is we're going to go class drawing, and it's not going to extend anything. That's just going to be a controller class. So this is like for handling bank accounts and handling cities, or in this case, handling shapes. And we're going to also pass that to save that guy. And here we're going to write another test. And notice how we're doing little bits and little bits and little bits, and that's generally how we do it. Try to do as little as possible. And we're going to just call it draw, sure, or maybe we should call it panel. Equals new shapes, drawing. And we're going to pass it the size, and let's make it 400 by 400. And again, I don't want to make these numbers exactly the same, so I'll make it 401 by 402, and that's just so I can check it. And then I expect panel dot width to be 401. It's just so they're a different number to make sure that it actually works. And then panel dot height to be 402. Save that, run the test. And it fails, of course, because there is no width and there is no height. So we'll go over to drawing and do the constructor. Okay. Now I'm just going to show something. This could be x, x, x width. It doesn't matter. As long as this dot width is equal to x, x, x width, that's fine. You can do that. Although most of the time we always make it the same. Let's save that and make sure it works. The next thing I'm going to do now, again, I'm going to just create a structure. So this dot shapes is equal to, and what I'm going to do is I'm actually going to use an object. And right now there's nothing to test here, so I'm just going to put that in. So I want to do the minimum amount of code I possibly can do so that I can begin to test it in the browser, just to make sure our philosophy is going to work well. So what I'm going to do is I'm going to get the drawing, because the drawing is the only thing I want to talk to if possible. I don't want to talk to those shapes in the background, because as soon as I start talking to those shapes in the background, all of a sudden I need to put a lot of logic in my index.js file, and I don't want to. So what I'm going to do is I'm just going to ask my drawing to create a drawing for me. So what I'm going to do is I'm going to, in here, I'm going to do, I don't know, create circle. And when I create a circle, I want to give it an X and a Y. And we're not going to worry about what that's going to do right now. All right. So we're just going to pass it an X and Y. So let's figure out from a test what we want this to do. So again, I would continue the test because it's part of the drawing. So I'm going to go panel dot create circle, and I'm going to want to put this at position 101 and 102.